Alright, this is the first video on types and variables. So I'm going to go in the Unity editor here. You'll see I've already created a script called types and variables. So I will double click that to open Visual Studio automatically. There you go. To double check, actually let's do this. So it should open Visual Studio. Just to double check, if it for whatever reason doesn't open Visual Studio, you can go into Edit, Preferences, and look here, External Tools, External Script Editor. Click here and you should have, as long as you have it downloaded, Visual Studio 2019, then you should be good to go. Alright, so back to this. Types and variables. Now, if you are familiar at all with algebra, programming at its core is very similar to algebra. So, we have something like, x, sorry, my IntelliSense, comment that out. So if I were to say x plus y equals z, for instance. So in algebra, we can take this equation and we can stick any value we want into x and y, and it will change the outcome. So if I put a 1, if I said x equals 1 and y equals 1, z would then equal 2. If I said x equals 2 and y equals 1, then we would get 3. So pretty simple. Like I said, this tutorial is designed for the absolute beginner, and I'm going to assume that you know absolutely nothing about code. So if you have coded before, know a little bit, just bear with me in the beginning of this tutorial, as we'll start speeding up soon. So types and variables. The analogy that I like to use, programming is about talking to a computer, explaining things to a computer. So if you imagine you're having dinner with a friend at your house, and your friend says, "Hey, can I use the bathroom?" Well, since you're talking to a human, you would say something like, "Sure, the bathroom is down that hallway, the second door on your left." Nothing unusual about that. Your friend gets up from the table, pushes his chair in, excuses himself, walks to the bathroom, steps over the cat who's lying on the ground, finds the bathroom and uses the bathroom. Pretty simple. Now the thing that you have to understand is when a human tells another human something, we can understand, we can make assumptions about what you're saying with very little information. The opposite situation in that analogy is assume your friend was a computer. Okay, so your friend says, "Hey, can I use the bathroom?" You say the same thing. "Okay, it's over there down that hallway, 2 doors on your left." Well, what a computer will do is it will get up, it will step over the table, it will step over the cat, or excuse me, it will step on the cat, it will try to walk through the hall or through the wall instead of turning and going down the hallway, because it doesn't make any assumptions. Okay, so when you tell a human something, he knows, obviously, don't step on the table, obviously, don't step on the cat. But when you tell a computer that, it will not make any assumptions. So basically, if your friend was a computer, you would have to say, "Okay, push yourself back from the table, stand up, strafe 1 step to the right, step 1 step back, step 1 step left, push your chair in, rotate your body at 110 degrees, for instance, walk 5 paces this way, rotate your body 20 degrees to the left, walk down the hallway 12 paces, take a left, there's the bathroom." So the point that I'm making is you have to be very, it's called explicit, very particular when you tell a computer something. So to come full circle, the reason why I say that is when you work with types and variables. A variable can be, any type of thing that I'm trying to tell a computer. "Hey computer, my number is this. Hey computer, my name is this." Stuff like that. I can't just say, "This is my number, this is my name." I have to be very specific. So let me take a tidbit or a snippet here. and give you an example of the types in C#. There you go. So these are the types, and you can see a few of them are numbers. Now, depending on how familiar you are with math, you know that there's not only one kind of number in math. We have something that's called an integer. That is 1, 2, 3, 4, 5, 6, 7, even 0, even -1, even -2, even -3. Those are integers. Basically, they are whole numbers that can go, as long as they stay whole numbers. That's the important part. They can also be negative or positive. Now, a float refers to basically a decimal point. So a float can be, 0.01, it can be 0.02, it can be 0.03. And you might ask why that's important. And it's kind of out of the scope of this video right now as to why that's necessarily important, but in a nutshell, when we tell a computer, okay, this is the type that I want to work with, when we tell it the kind of type ahead of time that we're working with, it can decide how much data in its own brain it wants to save for that number. So maybe this makes sense, maybe it doesn't, but basically, to say something like 1, hey computer, I'm going to have a whole number, it's an integer, save the information of an integer. It's easier for a computer to save the data of one single character than it is for the computer to save something as specific as this. So it needs a little bit more space in its brain when you know that this is when you tell it that it's going to be a float. So that's all I'll go into for that. These are numbers. Int is a number, float is a number. Those are the most common out of the number types. Now we'll go to string. String is very simple. String is just a snippet of text. That's all a string is. So John, Tom, that's all a string is, right? And we signify that we're using a string with the quotations. That's how we tell the computer it's a string. So that's pretty simple. Character is just a simple, a one-bit character or one character of a string. Pretty simple. A double is similar to a float. That's all I'm going to get into right now. We can get into more of what that is later, but these are the important ones. Now the bool, a boolean is basically a yes or no, true or false. Think of a boolean like a light switch. Either it is true or it is false. Now a better way, easier way for you to understand that is we normally use booleans in a way such as this. For instance, think in terms of a game character. If the computer has to check, you've killed an enemy and the computer has to check whether there are any valid enemies that you can still target, okay? Because you can't target a dead person, you can't target a dead enemy. So maybe those characters would have a bool value called is alive. And when they're alive, the bool value is true. And as soon as you kill that enemy, someplace in your code it says bool is alive, change to false, because now he's dead. And then whatever code you have running that's in charge of targeting new enemies, it will have a conditional check in it somewhere that says, well, I can only target a enemy that is alive. So this bool conditional check would prevent you from targeting an enemy that is already dead. Okay, so now that we've done that, I will kind of introduce some usage of those things. So not to get into too much detail right now, start. Whatever I put in here will run as soon as I press play. As soon as I press play, we're going to get something written in here. And one of the simplest methods I can use is a debug.log method. That just means that whatever I put in here is going to print out to the console. So Tom, anything in the parentheses will print out. And maybe you can assume what this is going to do. So let's try it. When I go back into the Unity editor, I have to attach the script so that it's actually active in the game. I'll go ahead and do that. I'll attach to the player. In this instance, it doesn't matter who it's attached to. I'll open up the console, which we've said before is where everything gets printed and all the errors are printed, so you can guess that this is going to print out to here. Then we press play. Now you can see I have printed Tom, and when anything comes from the console, you can double click and it will show you exactly where it came from. So that's pretty simple. This is a statement. It just prints that out. Now a way that we can use some of our types that we've created. I can do something like this. Tom plus Joe. Now I can add strings together, and this is, I guess, kind of an important part of why the types matter. Okay, one of the big reasons that types matter is when different types are interacting together through something like addition or multiplication or whatever it is, the computer needs to be able to decide if it's valid to do that. Now C# is a statically typed language, which means that, aka strongly typed, that I have to say something like int my int 1. Now my int is simply a variable. That's the actual variable. Okay, this is the type, this is the variable. So this is the container which my 1 gets stuck into, and int is simply the label of the container to allow the computer to know that my int is of type int. So with that being said, the whole point of labeling your types is so that the computer can know whether something can be added together, how those interact. A string can technically be added to a string. That's not always probably the best example to use, but if I go and save that, take a guess what that's going to come out with. And undo that, clear the console. Tom Joe. Okay, so it just bunches them together, right? And it knows it can do that because you can add a string with another string. Now, let me see the value of my Boolean. Okay, so whatever is in there, my Boolean, it's the value of true, is going to be basically added next to Tom. Tom true. Pretty easy. So that's the idea. The computer will allow me to add the string name of Tom to my Boolean, and we're going to get that value. Let's see if it will add my int. Okay, so it'll allow us that too. I'm going to save you the details on what that will do because it's probably pretty easy to guess. We're going to get Tom 1. We're going to get the value of my int. And the beauty of it is, being algebraic, my int is not necessarily a value. It's just a variable. So my int, think of it as a container or a cup that is holding the number 1. So if I don't change my int at all and I simply change the contents of it, what's going to happen is it's going to print 5 instead of the place of that. And then I could do something like my other int equals 6. Okay, and I can use that as well. And I know this is super simple, but my other int plus my int, if anybody can guess what that's going to do, these are two types. It's going to add them together, and that's going to come out with 11. So it knows that it can add an int with another int. We'll see better examples of how other types will interact with other types as we go on. It's kind of hard to think of a really easy example of when, it's kind of hard to think of a way to mash two different types together in a way that's going to give us an error right now, since we've only went over types and variables. But down the road, when we try to, you know, for instance, take the result of an addition statement with two numbers and stick it into, a float value, for instance, or a different sort of type, then we'll see some instances where we get an error where the computer basically says, hey, you can't convert these two types into that type. And then we'll kind of see the real power of types. But I think this is enough for now. This gives you the basic idea of what types and variables are. Just remember, int is the type, my int is the variable. So a way to think about it is, this is the type call, or not call, this is the type label. This is the variable name for that type, and then you put a equals, and then this is the value that I want. Don't do that. This is the value that I want inserted. So it uses that structure. The label of what our type is, the actual variable name that's going to hold the variable, and the value in which we want to stick in the variable. So that is it for now. Until next time.